Hello, my name is Dimitri, and I'm making this video to show off my out-of-band management device that I built for managing my networking lab at home. Um, it's been a very interesting project, and I learned a lot about how different serial to USB adapters work and how to manage these devices over the network, over out-of-band USB dongle, such as a MiFi device, how to set up the networking aspect of it. I've been using it, I don't want to say daily, but whenever I work on my lab, which is at least a couple of times a week. It's been very stable, it works great. In addition, I have two USB ports allowing me to connect a MiFi device. So it's something that looks like this. And this thing will allow you to access the internet from anywhere wirelessly. And you can configure it to not sleep, and that will basically give you out-of-band management. Meaning that you can connect to it without there actually having to be Ethernet connection to where the device is plugged in. So let's say the internet fails on this Ethernet port or this one or both. We can have the MiFi device take over, and we would be able to route inside here through there. So one thing that I have in place actually is once the device goes online, I'm able to connect to it through my OpenVPN server. So automatically we have a connection initiated from this out-of-band management device into my OpenVPN server, giving me full access to it. And I'm going to connect to it right now. I could connect to it directly, like I have. If we go 1 and 2, let's say 10, 143, log in, and have access to it locally, but that's no fun. It's good to have that option, but it's just one of the possible options. So I'm not gonna connect to OpenVPN from my computer. I'm gonna connect to OpenVPN server and work from there. So I can just do this. Credentials ready, and this is for. Yeah, I know root login is not good, but for this demonstration it'll have to do. VZ list, VZCTL, enter 104. And now we've entered, let's do this. We've entered a container which contains my OpenVPN server. I'm gonna go ahead and change the appearance to 18. And from here, we can ping 10901. Oh, by the way, this VPN server is located in Canada, so I live in New York. It's quite close, but it's not a LAN connection. So we can SSH with my name at 10.9.0.1. Right, and this menu is what I've written. Basically allows me to control any device that's connected to one of these serial ports. So it only controls devices that have a serial port connection, which is basically everything Cisco and I want to say Brocade, all the high-level networking equipment, as far as I know, has a serial port. Now they're coming out with USBs, but they still have serial for legacy. So if I would press 1, I connect to one of my switches, and I can control it from here. This is how it works. I get an IP address, port information. I can get out of this, go to a different device, and here I can log in as well. I have up to 8 devices. 9 is a planned upgrade, which I might do soon, but it doesn't exist just yet. So if I click it, it's going to fail. Doesn't know where to connect to. Not yet. Oh, I closed it. Let's see what number 10 does. Number 10 kills all screens because I'm using screen to actually create these sessions. So if I go into screen -ls, screen, oh, let's root sudo screen -ls. It's going to show me what ports are available. So also I have it written here in the menu, so it doesn't actually resume the session. It kills it. If I go to port 1 again, it's actually going to kill it instead of resuming it. It's just a better way of working out some bugs. Yeah, so I can connect to any of these ports through screen manually. Screen -r 7108 sudo screen, and I am inside the device manually. But of course, it's easier to do it through the menu. You can just clear all screens, go to port 1, get out. By the way, Control A and then D. Oh, I'm not in screen right now. So Control A and then D disengage the screen so I can get back to this menu. It's a shortcut. So that's what it does. Also, we can do Xmodem. I've written a small tutorial on how to do that. Very simple. And this is used for recovery if you flashed your firewall or switch and it didn't go through for some reason. Maybe you forgot to change the boot system file. And here you can log in into that device and upload, although really slowly, but you can upload the firmware and recover it that way, which is quite handy. Get out of there now. You can name these ports and do whatever you want. I just think this is an example. 3 I think is a switch right now. Yeah. And the reason I had to do this whole elaborate menu, so if you look at the menu, let's do sudo cat menu. Let's take a look at this. So I had to do some trickery here. The problem is the USB to serial adapters that I used, which you can see here, are quite cheap. These things cost, I want to say a couple of dollars, maybe $2 each. And the reason they cost so low is because they are they're fakes. I mean, they all have the same serial number. There's no identifier to them. Like if you buy a proper serial to USB adapter, it's going to have a unique identifier, and that identifier is going to allow you to easily manipulate it in a way that you can always control it so it's the same port all the time. And here I had to do this trickery in order for it to work in my environment. And the way I did it is so each port has its own configuration file. And this configuration file doesn't actually look at the serial port itself. It looks at the USB hub. So the USB hub has a unique identifier for every port it has. And this is the method that I used for controlling them. It's quite fun actually. About the build, it's pretty simple. I have a Raspberry Pi running Raspbian, a hub, USB to serial adapters, and a case. The case was actually the most expensive part. It cost me about $120, and it took a month to arrive. If I were to build it again, I would build something simpler. Maybe just Raspberry Pi and small hub in a encapsulated in case. Something portable that when I get into a site, I can easily um, just deploy it and control it remotely. Another aspect of this Raspberry device, it has a Wi-Fi built in, so I've actually utilized that and built a HTTPS. Um, so if I connect to the Raspberry Pi wirelessly, I can access SSH through HTTPS. This is how. So again. And now we have access through a browser, and this is just for ease of use. If I wanted to configure this device on my phone, I could easily get into it without needing a laptop or a workstation to work on it. And it's just quite handy, and that's just thanks to Raspberry Pi. Even though it's in an enclosure, it does reduce how far the Wi-Fi will work, but I would say within 5-10 feet you're fine. So 2 racks. This is my primary lab. This is the secondary. Here's the PDU, the Oobm management device. This is a 1900 switch. I'm sorry, 1800 switch, layer 3 device. That's a 3750 layer 3 switch, 3700 router, access switch, and ASA 5505. This rack I'm still working on. I got some Netgear switches up there. I have a layer 3 switch, a 3560, 1800 router, a blue socket wireless controller, and 2 access switches. So yeah, this is what I have to work with. My main rig is my ESXi server, which is right here, and the ESXi server serves for my viral testing purposes, and that's where I do a lot of my configuration testing as well. Here we see an unmanaged switch, which I'm going to replace soon. We have the DSR 8035. This is for remote controlling this server and other servers that I have around here. I have a PDU over here for battery backup in case the power goes out. I don't lose any data. And that's it. That's my home lab. And well, let me just show you how my Oobm management device is connected. Here it is. We see the console ports, and they are connected to the devices in the primary rack for testing purposes. So thank you very much. Thank you for watching my video. I'm going to try and make more videos on technical information, technical projects that I'm working on for fun, and release them to you. And hopefully you enjoy it. If you have any questions, let me know. Leave a comment. Thank you. Have a good day.